Hello and welcome. Today we're going to be looking at dilutions and the actual procedure that we take to do a dilution. So in a previous video, we looked at how to prepare 200 milliliters of a 3.5 molar solution by diluting a 12 molar solution. And in that math, we ended up determining that we were going to need 58 milliliters of the concentrated solution. So what we're going to do is go through that procedure of actually getting 58 milliliters of the concentrated solution and diluting it down to that 200 milliliters and end up with a 3.5 molar solution. So in this, I'm using 12 molar butyric acid, which for the purposes of this demonstration is really nothing more than just water with blue food coloring in it. Okay. This could be any type of solution, though. This could be a salt solution. This could be an acid like HCl. It could be a base like sodium hydroxide. So really any type of solution. But for this purposes, I'm using just this colored water. Okay. As far as equipment, we're going to use a 50 milliliter beaker, a 250 milliliter beaker, 100 milliliter volumetric flask, 50 milliliter volumetric flask, a 1 milliliter volumetric flask, or we could use a Buret setup. Okay, and this is something that I'll show you in just a moment. And then we're also going to be using a plastic pipette. So let's get to how this procedure works. Okay. So the first thing that I'm going to do is get my 58 milliliters of my butyric acid, my concentrated. And again, anytime that we're in lab, we need to make sure we're wearing a lab apron, lab goggles. If this were something caustic, like hydrochloric acid or sodium hydroxide, then I would definitely be wearing some type of gloves as well. So my butyric acid, this is where my 50 milliliter beaker is going to come in, and I forgot to have it sitting here. There we go. So my 50 milliliter beaker, and I'm using this because if I need 58 milliliters, this will give me approximately 50. So now that I've got approximately 50, I can get the actual 50 using this volumetric flask. So we carefully pour in. Again, anytime we're using a volumetric flask, we always want to make sure that the meniscus, that curved line, is going to be sitting right at the etched line. So I'm going to continue pouring this in slowly. So even though the beaker said I had 50 milliliters, see that I'm actually definitely way off from that. So get a little more of my stock solution. And as I approach that etched line, again, you want to make sure that the etched line is always eye level with you. So slowly pour in. And as I get closer to that etched line, now what I'm going to do is take my plastic pipette, squeeze the bulb, and let off of it, and it'll pull liquid up. And now that can go in, and I can start adding in drop by drop, so that I have 50 milliliters. Okay. So that 50 milliliters, I'm now going to take in my 100 milliliter volumetric flask, and I'm going to transfer it over. Put that into that volumetric. Then I'm going to take my 1 milliliter volumetric, and I'm going to fill this up 8 times and add to that 50 milliliters that I already have to get my 58. Now, if you don't have a 1 milliliter volumetric flask, that's where the Buret comes in. This would be set up on a stand. You would first clean this, but that's a different video. Make sure that the tip is filled. And this particular Buret measures up to 50 milliliters, but since I would only need 8, I would only need to fill it up about 10 milliliters. And on a Buret, the 50 milliliter mark is at the bottom. So if I fill this up, say 30, then as I'm adding, I would have 31, 32, 33. So I can do the subtraction to find out how many milliliters I've added. So I could fill this up to 30, and then in my volumetric flask, go on and open up the valve and measure out 8 milliliters, close the valve, and I'd have 58. Okay. If you've seen the other video, you know that we initially calculated 58.3 milliliters, but because of only 2 significant digits, we rounded that to just 58. If it had been 3 significant digits and I needed 58.3, well, there's not a way to do a 0.3 with a volumetric flask, and that's where you would have to use a Buret, because this is marked off in tenths of a milliliter. So I'd actually be able to measure out exactly 8.3 milliliters and have a more accurate solution. Okay. But because I can do just 58, that's where I'm going to use just the 1 milliliter. So I'm going to pour in, get it close to that line. Then I can withdraw using that plastic pipette. So there's 1 milliliter. I can add that in. Draw up some more. 2 milliliters. And I would continue doing this 6 more times to get my full 58 milliliters. Okay? For the sake of the video, though, I'm not going to make you watch me do that 6 more times. So we're going to go on and make the assumption that this is my 58 milliliters. Okay? Now, because this is just colored water, I'm able to go on and put it into that volumetric flask first. Okay? And then I can add water. If this were an actual acid, like hydrochloric acid, you always add acid to the water. So that's where the 250 milliliter beaker would come in. I would actually put my 50 milliliters into the beaker, then my 8 milliliters on top of that. I'd put a little bit of water into the volumetric flask and then add in the acid. Okay, a little bit of acid, swirl it, a little more water, swirl it, a little more acid, swirl it, until I get up to that 100 milliliter mark. Okay, so that's what you do with an acid. You actually store the acid, put in a little bit of water to the volumetric, then add the acid in. Because this is just colored water, or if this had been a salt solution or even a base, I can put that directly into the volumetric flask first. So picking back up, say this is 58 milliliters. Now what I would do is finish filling this up with distilled water up to the 100 milliliter mark. Once I've got that filled up to the 100 milliliter mark, then I would empty that into my storage beaker. Okay. So we're going to say that's 100 milliliters there. Then I would fill this up to 100 milliliters a second time, pour it in, and I would have my 200 milliliters of a 3.5 molar solution. So again, quick rundown. You get your volumetric flasks, get your volume of the concentrated. If it is an actual acid, it would go into a storage beaker. You would get your water in the volumetric, just a little bit, add that acid in increments, finish filling it up to that 100 milliliters, pour it off into a actual, your second beaker, and then finish out with the remainder of the water. Because this is not an actual acid, I'm able to put that solution directly into the volumetric and then add the water to it and get my total volume of 200 milliliters eventually. So hopefully all that made sense. If not, feel free to drop me a comment and I'll be sure to get back to you as soon as possible. Thanks.